Real quick review. When we do long division, think of something like this. 625 divided by 25. Do you guys remember how to do this? So let's review real quick, because when we do long division of polynomials, it's exactly the same algorithm or process. So normally what we do is we go, all right, I don't know, but I have a 2 in the front, that's 20, and then plus 5, right? You guys remember that? The 2 is in the 10 spot. And so 25 is right between 20 and 30. So we have to guess. Sometimes it works, sometimes it doesn't. Well, because it's 25, I'm going to think to myself, how many times does that go into 62? Okay? And here we guess. If I say 3 times, in other words, because 2 goes into 6 3 times, I could write the 3 up here and then multiply it out. So then I would say 3 times 5 is 15. Carry the 1. 3 times 2 is 6, plus 1 is 7. That's way too much. That's okay. It's not the end of the world. I just go back. Well, 2 was too much, so now what do I guess? 2. But I'm going to put the 2 right here over the 62. We also have to line these things up. Okay? We're technically thinking about 25 going into 62. So the 2 goes above the lowest digit of what we're multiplying by. So now I multiply it out. What's 2 times 5? 10. I carry the 1. And then what's 2 times 2? 4. So then 4 plus 1 is 5. I write the 5 down. So that 2 times 25 is 50. Okay? Now what do I do? I subtract that. Okay? Now I'm going to use a fancy math word. It's called negate. All right? I'm going to add the additive inverse. Right? The 50 is positive. The negation of positive 50 is negative 50. I know this sounds like really fancy stuff, but we subtract whatever we have. What happens if you subtract a negative, though? When you minus a minus, what are you really doing? Adding. Keep that in mind, because we're going to do that in a second. All right, so if I subtract 50, 0 from 2 is 2, and then 6 take away 5 is 1. What do we do next? Drop the 5. So we bring down the 5, and then I got to think to myself, what do I multiply 25 by to get 125? Does anybody want to take a guess? 6 or 5? Let's start with 5. And 5 isn't big enough, then we'll try 6. So 5 times 5 is 25, right? Put the 2 up here. What is 5 times 2? 10 plus 2 is 12. And what do we do now? Subtract. We have a remainder of 0. You guys remember all that? Now let's do the same thing, except now we're going to say 27 into 6. Oh, no, not 27. I want it to be 25. So say 25 into 627. Well, it's basically the same thing. I'm going to multiply the 2 here. That gives me 50. I'm going to subtract the 50. That gives me 12. Bring down the 7. Multiply by 5. And that gives me 125. And I subtract it. But what's the remainder? Yeah, I have a remainder of 2. Now, do you guys remember this? Essentially, what I'm saying is, in this first one, I'm saying 25 times 25, and you could write it like this now that we're in Algebra 2. 25 times 25 equals 625. Now over here, this is a little different. Our answer would be different. What we're really saying is that our solution is 25 plus, what do we add? 2 over 25. So we take the remainder. So remember that the remainder 2 gets put on top of the divisor. Okay? But it's the same thing. If I were to multiply this by 25, I would get 25. So that's the process that we would go through. Well, what does this have to do with polynomials? Does everybody have this written down? Can I move on to the next slide? I'll give you a second to finish copying it down. Okay. Are you guys ready? All right, here we go. So we do the same exact process with polynomials. It's just we got to think a little bit more. So when I say something like this is example number 1. I just wanted to remind you guys about long division. If I say to you, what is 4v to the 5th power plus 2v to the 4th power plus v to the 3rd power divided by 2v cubed. All right, so now let's think about this. I'm going to write it out as a long division problem. This 2v is what we is called the divisor, and that's a fancy math word that means that that's the number we're dividing by. And then underneath the long division symbol, we're going to put 4v to the 5th power plus 2v to the 4th power plus v to the 3rd power. How many v cubes is that? In other words, what's the coefficient right here if you were to guess? 1. So just write the 1 in there. Okay? All right. Now we're going to do almost the exact same thing we did before. Look at the 2. Look at the 4. What do I multiply 2 by to get 4? 2. All right, so I put the 2 here. I write it right above the term I'm dividing by. Now, the next thing I want to know is, what do I multiply v to the 3rd power by to get v to the 5th power? Yep, v to the 2nd power. Somebody said 2. Now, at this point, this is a good habit that Mr. Adams has developed. At this point, I multiply it back out. Just like that other problem, we multiply it out. So what's 2 times 2? 4. What's v squared times v cubed? Now, you got to remember that v squared times v cubed is the same as v to the 2. Remember the shortcut? You add those numbers, which is v to the 5th. And the reason we add them is v squared is v times v, right? What's v cubed? It's v times v times v. How many v's do you see there? 5. That's what. But now, probably in the 6th grade, we teach you this. Right? But there's another rule where you multiply the numbers. We're not using that rule today. That's a different thing. That's when you raise a power to a power. All right, so it's v to the 5th power. Now, think of the long division problem we did before this. Now what would I do? Subtract them. What's the remainder there? What is 4v to the 5th power minus 4v to the 5th power? Yeah, it's just 0. What was the next step in that process? Bring down the next term, right? So the next term is, and I'm going to draw this line all the way across. This is 0, but I'm going to put plus 2v to the 4th power. Now, what do I multiply 2v to the 3rd power? Well, let's do the numbers first. What do I multiply 2 by to get 2? So what I'm doing is I'm thinking, what do I multiply this by to get this? 1. Is it a positive or negative 1? Positive. So I'm going to put my plus sign here. Remember? I remember when Mr. M said there's a reason. I want you to think of the positive and negative and the plus and the minus. Kind of think of them as the same thing. They're not really, but... Alright, so I put my plus 1 there. Now, what do I multiply v cubed by to get v to the 4th power? What's that? 1. Yeah, v to the 1st power, right? So just v. Multiply it out. 1 times 2 is in fact 2. V times v to the 3rd power is v to the 4th. Now what do I do in that process? Subtract it. Okay? Okay. That equals 0, so we just leave it alone. What do you think we do next? Yep, we're going to bring down, way down here, v cubed. Well, here's an interesting thing. What do I multiply 2 by to get v? Well, this is really 1v, right? 1v. What do I multiply 2 by to get 1?
0.
That would be 0.
So negative 0.5.
You could do that. And it wouldn't be negative, it would be positive. You could do that. But 0 is the right kind of vein. This is technically our remainder because 2v cubed does not go into 2v or go into 1v cubed. Okay? So let's call this our remainder. So then what did we do with our remainder on our other problem? Well, our solution then would be 2v squared plus v plus the remainder, right? The remainder is 1v cubed. And then that goes over the divisor, which is 2v cubed. Can I reduce that fraction? Sure. V cubed. What's v cubed divided by v cubed? Anything divided by itself equals what? I think I heard it out there. 1, right? 3 divided by 3 is 1. 7 divided by 7 is 1. Negative 1,000 divided by negative 1,000 is 1. So v cubed represents a number. Any number divided by itself equals 1. What's 1 times 1/2? Just 1/2. So our final answer would be 2v squared plus v plus 1/2. Now what Miles said would have worked too, because Miles said, well, wait a minute, what if we take 1/2 of 2? Wouldn't that equal 1? Yeah, that would work, but I got to show you how to use the remainder. Okay? So that is technically the answer. Does anybody have any questions?